let's move on to our next speaker, and that's Krishna Vedela, and he'll talk to us about the observing logbook. Go ahead, Krishna.
Hello, everyone. Hello, everyone. I'm Krishna Vedela from Toronto. I want to talk to you about an astronomy logbook that I thought was quite helpful for me to record my observations whenever I do stargazing. We all know we all started observing skies at some point in our life. Usually, it started with watching the night sky, just sitting there with our family, friends, and slowly we start upgrading ourselves, graduating to telescopes, like you see on the screen here. Sometimes you might be driving on the side of the road and you would see something quite interesting up in the sky. Um, for example, to the left-hand side, bottom left of the screen, you see what I thought I was picturing an aurora from right here in Toronto. In fact, outskirts of Toronto. Whether it is true or not, I wouldn't be able to know until I go back and check the records if that is indeed the fact. Um, Not only that, sometimes you might be observing the sky, or maybe in fact taking a picture of a celestial object. To the right hand side here is a blue snowball nebula. It is an NGC object, quite faint, easy to detect from an 8-inch telescope, or at least that's what I heard. And so I spent about 4 hours trying to find that object, and unless I know when I did that, what time I recorded, what were the sky conditions at the time, I wouldn't be able to go back and recreate the same situation and save spending 4 hours looking for it again. And that leads us to recording these observations. These are some examples of how others have recorded what they observed going back to 1800s. And in fact, these observations, these recordings, or these notes that they made at the time have proven quite useful not only to them, but for later researchers who look back and see what was the magnitude of the star at the time, what was the shape of that object at the time, did it change from then to now, and so on and so forth. Now, their handwriting can be quite legible, like the one here on the left hand side, or it can be completely illegible. However, it is an observation nonetheless. And RASC has provided good PDF files to record such observations, to make such recordings in a very concise and an organized fashion. So the left hand side is a snippet from RASC Messier object certificate program, where we can record what the object is, at what time did we record, some of these details, and it also allows you to make some additional notes that you can add per the observations on at that time. And it is very important for us to do so because it promotes citizen science. Like I said, it allows us to come up with new discoveries. What we saw before, there might be a star that you have not seen, but today it doesn't appear anymore, um, which could mean that probably it's a supernova explosion or something like that. So it is very important for us to do the record keeping of these observations, whether we do it casually or whether we do it for scientific purposes. When we try to do these recordings in a dark sky situation, there are plenty of problems that we face. First and foremost, it is very difficult to write on a piece of paper or in a notebook when we do not have a table with us. And carrying a table along with your telescope, along with your observation equipment and all of that, it could be quite a daunting task. um, the papers, if we write them on our if we write them if we make our notes on a piece of paper, it it doesn't stay for too long. It can get destroyed if water spills on it, or if you put a coffee on it. Uh, we cannot even search through those notes. In order to go through and refer to a note that I made back in 2018, I would have to go through a notebook dated 2018, rumble through the pages, and then find out which one that is. Um, So, but today we are living in a 21st century. Can we come up with a solution for all these problems? And that's exactly what I thought to myself when COVID hit, and we were in the lockdown, couldn't go out anymore. So, okay, let's look at these problems and the solutions that we can address one by one. Legible handwriting, we can replace it with keyboard typing. If we are in a dark area and we don't have a piece of paper, can we use our smartphones or a tablet screen to do that? Yes. Similarly, we can if we are able to store these information in electronic format like an Excel spreadsheet or some kind of a database, then we can go and search through them with a single query, or in a more electronics in a much more rapid fashion. And that gave me the requirements of what I needed to do, because this was the problem that I was facing myself. Every night I would go and observe, trying to get in order to work for my Messier certificate. I would I would take a couple of pieces of paper or note. In fact, I have a notebook with a red light. Try to write down my notes in there. Come back home, fade it into that PDF file. All of this was quite inundating, and I thought, we could do it much better. So I needed to come up with some solution that would work on tablets, phones. In fact, even web. I do not need a particular type of device. If I can store all my data in a web-based platform, then I can access it from anywhere. I do not have to restrict myself to observing within in the vicinity of my home, with where Wi-Fi is available, or go far when I travel outside of Canada. In fact, I can still access it and update information in there, because it has to work in a dark environment. I need to make it in a night mode. That is, all the text would be in red and the background is black, so it doesn't affect my night vision. The data, whenever I store it in the cloud, I want to keep it secure, and nobody should get access to it. Today I'm storing just my observing information, but tomorrow I might store something else. So I need to make it future proof. I need to have an ability to go through and search through the observations, filter out, and select which ones I want to look at again. For example, give me all the instances of observing the Crab Nebula. Like one of the previous speakers mentioned, it would keep changing its shape over a period of time. So if I observe it today, I want to make sure if I observe it again 10 years later, has there been any difference? Did it change in its brightness, or is it still the same? Or in fact, has it gone bigger in the conditions of my field of vision? Then, in order to get my certification, I want to at the end be able to convert all that information, all those observing sessions, into a convenient PDF file that I can give to our ASC, and hopefully they would accept it and say, yes, you get the certificate. So I should get that. Um, Similarly, I want to be able to know if I go out tonight, what are the Messier objects? What are the objects that I would be able to see immediately? I do not want to go to another app and figure out, okay, in this location, in this given period of time, which of these Messier objects are visible. So, as a convenience, I wanted to have that ability to show up as well. That led me to build this app called as that I call Astronomy Logbook. It starts with a simple sign-in page, and it gives you the ability to sign in using Google, Apple, and Facebook. So I don't want myself or anybody else using it to worry about passwords, to worry about a new login information, and whatever existing login authentication mechanisms you have, you can continue to use it. Just one less thing to remember, one more simple step. And this is the once a person logs in, you're presented with your list of observations that you have done so far. So as you can see, it's a scrolling list of every observation, and each observation is presented to you as a tile. On the top is your title. If you have a Messier number that mentioned in it, you can have that. That is presented over there, and they're all organized in the descending order of observation date. So the newest observation is on the top. The oldest observation would be at the bottom. And this list is loaded continuously every time you make a change. Now, let's say I'm in a location where there's no internet, there's no cellular connectivity, there's no Wi-Fi. In those situations, the data gets stored locally on the phone. That gets presented. And if you make any changes, those changes also get stored locally. And once you have connection to the internet again, that would be updated automatically in the background. All that happens seamlessly without the end user getting affected or even being aware of it. The On the top is a list of all these filters that I have, a search window where you can search for Messier objects, you can search for NGC numbers that you have observed, or you can actually search for the observations in a certain date range between from the 1st of January to the end of January. How many observations have I done so far? Things like that. And once I have a shortlisted items, once I have shortlisted the items, I can uh, long press any of these tiles to select them. And when I click the PDF button on the top right, it would simply create a PDF page for me, like so. And this PDF file would have the name of the user on the top left corner. And as a future add-on, I was thinking of adding a digital signature that would ensure and authenticate the PDF that was created. And this PDF you can then simply share with any user, or in fact even RASC. How can I record the observation? If you look at the on this observation page, on the bottom right corner is a plus button. When you click that plus button, you are led to record a new observation. And in this page, you're presented to enter title, the Messier number, the NGC catalog number, if any, if you have to, but the title is important. The latitude and longitude values are acquired automatically if you authenticate the application to use your GPS location. Similarly, the address location is also auto-filled from on the Apple or Android devices. This tool is also available using a web interface, but on the web interface, some of this information you need to have to fill in manually. And so while recording the observation, you can also mention which equipment was used, what were the seeing conditions, and you can add as many note points as you can to the list. It can be 1, 10. You can edit, delete them today, tomorrow, anytime you want. This is an example of one of such observation that I made, where I have about 6 notes that I've done here. Swiping any of these notes can remove that particular note. You can add more notes later on once you go back home and you think, "Oh, this is what I remember seeing." You can add that on later. Um, List of equipment. So once you have, you as I said today, you might have an equipment consisting of an 8-inch telescope. Tomorrow you might upgrade it to a different 8-inch telescope, or even a 10-inch. Or it might be that you went to DDO and observed using the big scope. In that case, you can absolutely add this information in here, and so that you can continue making your observations and keep storing them. Um, for posterity. One important thing that my wife and I thought of when we always go stargazing is the checklist of equipment that we want to take. And it has been numerous times that I forget one or the other. So I added a simple a checklist option where you can add your own items in there. And every time you go, while packing up your equipment, you can check each box, and once you're coming back, you can uncheck each of them in order to make sure whatever you took came back with you and you did not forget accidentally anything at the observing site. And this is the Messier list that I added recently, and that was quite challenging, also fun to do. Um, so this list is a list of all the 110 Messier objects. Number one, two. Um, the entire Messier catalog was uploaded using an Excel file to a central database, and that includes the right accession and declination information for each of them, and some information like what kind of a target it is. Is it a supernova remnant? Is it a globular cluster? Is it an open cluster? How easy or difficult is that target for us to observe? So with RA and declination, and knowing the current location where the user is, the cell phone in fact, um, I went through and searched, come up with went through the list of all the equations and came up with a simple structure that can compute the rising time and setting time for each of these objects on the fly and present to you in this over here. Because as you know, based on your location, based on the time of the year, the rise and set times for these objects would change. And depending on that, you can figure out which of these objects would be visible in the night sky tonight, and which of those would not be. So on the right hand side, the extreme right hand side, the X mark or the check mark indicates whether the time window, the rise time and set time, falls within the night period. And if it does, it gives you a checklist, check mark. That means you can go and observe it tonight. Otherwise, you see an X mark. That means you cannot see it. It would not be so easy for you to watch in the night sky tonight. And on the extreme left hand side, it also shows you which of these objects have I actually observed before. So for example, M1, the Messier 1, I had observed it before, and that's why it shows me that I symbol. Whereas M9 um, is something that I haven't seen so far, so it shows me that I symbol with an oblique sign in front of it. So in a very convenient fashion, I can go through the objects that I have not seen yet and which are visible tonight, and check them off my bucket list. So I would be one step closer to achieving my certificate. It was easy for me to build it over a couple of months, and I initially built it for myself. And I thought if people might find it useful, so I let it um, uh, distribute. I distribute it for free, and you can download it on Apple Store and on Google Play. You can also try it on the website up there, astrolog.vedala.holdings. All the communication happens through encrypted channels, the HTTPS protocol, and the login information stays secure with the user themselves. And also, what I intended to do, and I have done, is that I have released all the source code for this project for free on a repository system called as GitHub. So if you're interested, feel free to let me know, and I would be glad to share that information with you. Or if you actually search for Astrolog on GitHub, you should be able to find it. The code is pretty straightforward. It has been documented um, uh, for for everybody to use it. And if you are a programmer, you can absolutely create your own repository and develop your own app and install it for your own use without having to rely on the backend infrastructure that I had set up. I initially conceptualized the project in February 21, and over a period of time, slowly developed it, improved it, and had a lot of fun using it myself. Um, for whoever is technical in nature, this is the technology stack that I use. The backend uses Google Firebase. It is free for the application that I have, at least for myself. And even if many people start using it, it would still be free, unless it gets quite big, and then charges would kick in. Um, but in order, there are ways to get around that as well, and it's quite easy to do so. So I'm not too worried about it. Future plans. So today I have the Messier catalog listed in. I want to add the NGC and the Caldwell as well. The user interface, it works for me, but I'm pretty sure for various other people, we can adapt it and improvise on adding more features and more information to it in a concisely, in a non-cluttered way. Computing the rise and set times was fun, like I said, and the equations. The funny thing with this was the equations were not clearly mentioned anywhere, and there's no one location where I could go and say, hey, if I have RA, if I have declination information, latitude, longitude, and the date time in UTC format, these are the steps to do so. So that's why I documented all of that, and I would be uploading that information to the GitHub repository for people to be able to access it as well. So, given having said that, this has been very fun for me to do and to record my observations. I hope you guys find it useful as well.
Thank you very much, Krishna, for sharing this with us and for the hard work and for, of course, sharing the source code for anybody who wants to continue the development. That's fantastic. We can see how capable our members are. It's quite something tonight. Lots of good stuff being shown. All right. Do we have any questions for Krishna, Emma?
Yes, we have a couple of questions. The first one comes in from Ralph Chu. He says, it looks like a great way to record observations for the Observer's Pins programs.
Thank you. That was my intention. I wanted to do it for myself, and it just grew and thought it would be there's more scope to this than what I initially intended.
Cool. Andy says Andy wants to know, for a future version, could we please get a place to enter variable star observations?
Absolutely. So in the future, that's the next thing I wanted to. There are a couple of projects that I wanted to evolve this into. One was to be able to send a CCD camera information directly to this app, and it would figure some of these things out direct on its own, or enter the values manually. That is one of the things that I wanted to add. The other thing that I think would be interesting is to add the ability for people to add sketches right there on the tablet or the phone. So these are the two items that are on my list. I just need to prioritize which one to go first.
Cool. Thank you. And Ron wants to know, might you use your system for a Messier marathon next month?
Absolutely.
Yes, that's all the questions we have for tonight. Thank you.
Very good.
Thank you.
So Krishna, software is never complete, right? It's never finished. It just keeps evolving, more features and so on. So I'll reach out back to you in a little while, maybe a year or two, and you can give us an update.
Absolutely.
All right. Very good. So that concludes our speakers for this evening.